Whilst it's great to have the option, decision making isn't always fun, and it would be fantastic if we had some way of lifting this weight off of us and having something make the decision for us. Yes, you could load up an LLM and ask your AI buddy what it thinks you should do, but sometimes life calls for a more analog solution. In this video, I'm going to show you how you can quickly and easily generate your own custom dice with anything you want on the sides, whether it be numbers or instructions or logos or images. You can use this to create your own custom dice for gaming, or create a bespoke set of decision-making dice for a decision that you regularly need to make. So, let's have a look. Before we get started, I just wanted to drop an important caveat. At the time of recording this video, this process is only capable of producing a 6-sided die, so unfortunately this video is going to be D20 free. I will in a future video, however, be covering a slightly more involved process in how you can produce a custom D20. So for now, let's get stuck right in. This process is going to be using a piece of software called LuBan3D. That's not Luban from Snapmaker. This one is available for Windows, Mac and Linux from LuBan3D.com. You can use it for free with slightly limited functionality and export quality. There is a free 30-day free trial with full functionality, and then there are various paid licenses available beyond that. So let's get it downloaded and booted up, and we'll get started. When you boot it up, you'll be presented with a very basic retro user interface, but don't worry, this is really easy to use and I'm going to take you through it step by step. Head up to File, then go to Create, and then select Dice. It will now load a 3D model of a traditional die with dot-based numbering on each side. You can scroll up and down on your mouse to zoom, left click and drag to rotate around the model, and middle click and drag to pan. Click Browse next to Select Template in the top left. Here you can now navigate to and select the images that you want to display on the sides of your die. You can choose whatever you like here, whether it be logos, images or text. Technically you can even apply photos, but unless they are particularly simple photos, I find that it can crash my pretty beastie computer when selecting them. You can select one image and it will be repeated on every side. You can select 2 images and they will be used on 3 sides each. And you can keep going until you have 6 images and there will be a different image on each side. Once you've selected the ones that you want, click Open. You're now able to look around the die and make sure that it's loaded the correct images that you wanted and place them where you want them. Once you're happy with your images, you can then move on to the other settings on the left, and we'll go through them now. The first setting that we have is size. This is the dimension of the dice in millimeters. You can see the dimensions also marked on the grid on each axis, so you can use that to help gauge the size of specific parts of your images and how big they'll be when it's printed. By default, the size is set to 20mm, but whilst die can vary in size significantly, the standard size for conventional 6-sided dice is 16mm. You need to press return on your keyboard once you've changed the value in the settings for it to take effect. Just clicking away or clicking into another box doesn't do anything. Beneath that you have corner radius. This can be set to any number between 0 and 10, with 0 having straight corners and 10 being so curved that the images of the faces on the die are cropped into circles. I find that 3 is my preferred figure here, but it can crop the edges of the image, in which case I generally switch to 2. Next up we have edge chamfer, and as the name suggests, this chamfers the edges and corners of the cube. If we set the corner radius to 0 and adjust the chamfer, you can better see what it's doing. The highest you'll likely want to make this is 4, as any higher and there's a good chance that the die won't be lying on a side when it stops rolling, and if you switch this to a significantly high number, then it can completely change the shape of the die. By default this is set to 0.5 and that generally doesn't need to be changed, but you can find a good balance that works for you between corner radius and edge chamfer. The final setting we have here is extrusion. This is how far you want your images to be cut into the die, but technically it can be used to have the image extruded out of the die, though that would mean that the die wouldn't necessarily work properly. A negative number is the distance in millimeters that it would be cut into the die, and a positive number is the distance in millimeters that it would be extruded from the die. I'll assume that most people are going to want to go with a negative number here. The figure that you choose will depend on the look that you're going for and the hardware you're using to print it. If you're printing this in a single colour, you're going to want to use a depth deep enough to clearly show the numbers without them being coloured in. In that case, something between -0.2 and -0.4 is probably good. If you're going to be printing this in multiple colours with something like an AMS or an MMS, you've got another choice. You could either aim to have the text as flush as possible with the side of the die, only visible due to its difference in colour, or you could still have it slightly recessed. If you wanted to go for the former option, having it flush with the surface, what you want to choose here is a distance that is smaller than both the size of your extrusion lines and your layer height when printing. This means that when it comes to painting in your slicer, there will still be a geometrical difference there, so you'll be able to use the fill tool to paint it in. But because the distance is smaller than your layer height, it will all be printed on the same layer still. For doing this, I tend to use 0.005mm, so here we'd use minus 0.005. If you wanted to have it slightly recessed, then you could go for something similar to my single colour suggestion of minus 0.2 to minus 0.4. With your extrusion distance chosen, it's time to export it, so click Save Model. LuBan doesn't allow you to choose a file name on export, so navigate to where you'd like to save it and click Select Folder. This will then create a new folder in that location named after one of the images that you used, and it will then save the die inside that both as an STL and an OBJ. With that exported, let's get it imported into our slicer. I'll be using Bamboo Studio for this, but the same will apply in whatever slicer you're using. Let's get this imported and take a look. Now, I actually created two versions of this die with two different extrusion depths. One set to minus 0.3mm and the other set to minus 0.005mm, so I can now show you the difference when painting them. On this one you can see that the logos are clearly visible, but on this one you just get a faint outline. If we select it and go into paint mode, I'll select the fill tool, and then as I hover over the model you can see that it clearly indicates the areas that I would like to fill at each point. So now I can super easily fill in the areas of the logos. If you've got lots of little bits like this one, it may actually be quicker and easier to set the default colour of the die as the colour that you want the images to be. Then use the fill tool to just fill in the areas around the images, making sure that you catch any little gaps that are separated by the text and the images. This process will be exactly the same for the other version of the die. If we slice it now and slide down to the bottom layer, you'll see that on the one with a minus 0.005mm extrusion, the logo, whilst technically modelled on a different height, is printed flush on the same layer as the rest of the die. Technically, on these sides there will be a very slight recess, but so small that you likely won't be able to notice it. Let's get rid of this one for now, and we'll just stick with the one that will print flush. As you'll literally be throwing these around, I'd suggest using 3 to 4 walls or perimeters, and then you can just leave the infill on something simple like 15% gyroid, just adjusting it if you wanted to change the weight. With the current settings, a 16mm die printed with 4 wall loops and 15% gyroid infill in PLA is estimated to weigh 4.4 grams. A traditional 16mm die tends to weigh around 4.1 grams. If we wanted to try and match that, we just need to decrease the wall count to 3 and then increase the gyroid infill to 22.5%. Then we get an estimated weight of 4.1 grams, perfectly matching that of a traditional 16mm die. You'll want to select a layer height suitable for the level of quality that you want from the images that you've applied, but the rest of the settings that we haven't talked about can pretty much live on default. Though, if you did include a more significant recess on your text, you may want to make sure that supports are turned off, as they'd be a pain to remove from within the text and image holes. Alright, let's get this printed. Well, that did exactly what it said on the tin. It was a quick and easy process of producing a custom die. It required very little input from me, and here it is. Here is a custom die. It is the right size, the right shape, the right weight, and it has my own custom images on the side. I got a bit carried away with this tool and made a bunch of custom dice for making all sorts of decisions. Whether you want to make decision-making dice or your own custom dice for playing your favourite game, if you found this video useful, please do hit that like button and then hit the subscribe button if you'd like to see my future videos. Don't forget you can get a members discount at 3drevolutionstore.com by hitting the join button and becoming a channel member, then also getting early access to my videos, exclusive access to the 3D Rev Discord community and a bunch more. Thanks very much everyone, and until next time, happy printing. Thanks for staying right to the end. You guys are the real MVP, especially if you're one of my channel members. If you like this video, why not check out one of my other LuBan3D tutorials or one of my other 3D printing tutorials, makes or explorations. Thanks very much everyone, and until next time, happy printing.